So, given this function as it's defined, first thing we want to find is basically f of 3. Now this function is defined as f of x, right? So what this 3 represents right here is a value that I should be replacing x with. Now if I do that, the only x that I see for this function as it's defined up here is this x at the top. So plugging in 3, there's that new interval, right? As it's defined for this definite integral, and apply to the square root of 2t squared minus 3 with respect to time. What's that going to equal? It's going to equal 0. Right? We've got an interval here that's not going anywhere. So as far as area is concerned, beneath this curve, there's no value. The value is 0. So the first part here is pretty easy. The second part, though, what we do is we look at the first derivative as it's applied to this function. And we look at that first derivative when we take 3 and we plug in. Now, if we're going to evaluate what that is, the first thing we need to find f prime of x. We need to figure out what that is, whatever that is, then take 3, plug in. Well, thinking about what that means to find f prime of x, that means go back up here to my function as it's defined, basically apply the derivative to it. So f prime of x equals the derivative of this function. Now this notation should look familiar, right? This is what we saw last time when we talked about the second fundamental theorem. We see this little d dx right here. That's supposed to tell us to do something to this function over here. And what it's telling us to do is apply that second fundamental theorem. So we start by taking the x on top. We plug in for the variable t, right? We get the square root of 2x squared minus 3. Then the idea is after you take that x you plug in, tack on down here the derivative of x, which is just 1. And then subtract, right? We subtract, we take this 3 here, plug in for t, get whatever that equals, and then tack on what to that? Okay, it's 0 because that's the derivative of 3. So I've kind of explained my way through all those pieces, right? I didn't write them all out. But the reason I didn't write them all out is because this is just going to simplify to the square root of 2x squared minus 3. Meaning if I want to find f prime of 3, take your 3, insert in here for x. F prime of 3 is going to equal square root of, it was 2 times x squared, right? So 3 squared. And what was the rest? The rest was minus 3. So 3 squared 9 times 2, 18, minus 3, square root of 15. That's f prime of 3. But to get to that point, that's where we're seeing our new application here using the second fundamental theorem. All right, the last part on problems of this type. Usually we like to take things a step further. A step further than the derivative would be the second derivative. So f double prime this time, sticking with that value of 3. Well, just like on part B here, if we were going to find f prime of 3, we got to find f prime of x first. First thing we want to do here is find f double prime of x. Well, how do you find a second derivative? You take the derivative of the derivative. So we know that f prime of x equals the square root of 2x squared minus 3. So let me bring that over here. F prime of x equals square root of 2x squared minus 3. Find the second derivative. We're taking the derivative of the first. First, we understand what that root would be 2x squared minus 3 raised to the 1/2. So we'd have to bring down that 1/2. Rewrite the 2x squared minus 3 raised to a new power of negative 1/2. And then we're using a chain rule here. We got to multiply by the derivative of 2x squared minus 3. 4x. And then we get this scenario here where it's been a little while since we've seen it, but we notice that everything's linked together through multiplication. We got a fraction, we got negative exponents, so this would simplify to a fraction of some sort. Recall how we've got this denominator of 2 right here. We'll put that on the bottom. We've got this negative exponent expression. We'll bring that down to the bottom. Change that to a positive power. And then anything else just stays on top, right? Anything else would be this 1 and this 4x. So to find f double prime of 3, we got to find the second derivative first. Now we've got the second derivative. So let's take 3 and let's plug in for our x's down here. Plugging in, f double prime of 3 is going to equal, now let's see, this would be 12, right? Could reduce with that 2, so we could say 6 on top. Now this should look familiar, right? Because this is the square root of 2x squared minus 3, which is the same thing we did up here, and we got the square root of 15. If we don't simplify any further, and I'm okay if you don't simplify any further, we now know what our answer is for f double prime of 3.